Good afternoon, and thank you for signing up for this webinar. My name is John Altier, and I'll be presenting this seminar, and Michael Owsley is also here. He's taking care of the technical aspects of this seminar production. Today, we will be talking about venting problems and possible solutions. We will be conducting some polling questions during the seminar, and I really encourage you to take part in these. It's great feedback for us, and it helps us understand the markets you are seeing out there today. You also have the opportunity to ask questions, add comments using the chat box on the lower right hand of your screen. On the top of the screen, there is a green light indicating that we're recording, and next to that is a hand symbol. During the presentation, we'll be using this to communicate, so let's make sure it works. We will have a copy of this webinar archived on our website in the coming weeks. Today, we will be discussing problems that can occur with venting a fireplace or stove, why they occur, and what you can do about it, what you can do to correct the problem. We will also briefly discuss the principles of draft and flow and the difference between mechanical and natural draft. So what does draft really mean? Well, here's the definition from NFPA 211. Draft is the pressure differential that causes the flow of air or gases through a chimney, gas vent, or venting system. Or you could explain it this way. What are thought to be draft problems may actually be chimney performance problems, and they are seldom caused by inadequate draft. They are more often caused by poor design and caused by the chimney itself. There are two major factors to consider when working with chimneys: draft and flue gas volume. Draft is the force which causes the flue gases to be exhausted. The flue gas volume is the amount of products of combustion from the heating appliance passing through the system as a result of the draft. The size of a chimney should be based on flow requirements, as any chimney size has a certain capacity in regards to the amount of flue gases it is able to remove safely. A good analogy is drinking straws. Blowing into a straw is more difficult than blowing into a large straw. And you can blow more air through the large one than a small straw. A chimney works in the same way. A greater volume of air can flow through a larger flue more easily than a small one. Two major factors that influence the chimney capacity: draft and flow resistance. Flow resistance is a result of friction and always exists between the moving gases and the chimney through which they flow. Bends and elbows cause flow resistance, but even a straight pipe can cause flow resistance. It's simple, but it's not a very strong force, and it is also highly influenced and affected by its surrounds. So now, what is mechanical venting? Well, the definition of mechanical venting, it can be found in NFPA 97, which is the standard relating to chimneys, vents, and heat-producing appliances. That provides an induced draft. Now, forced draft is where a fan is located so as to push the flue gases through the chimney or vent. And induced draft is where a fan is located so as to pull the flue gases through the chimney or vent. Obviously, a mechanical draft system cannot be used in any stack or chimney exposed to habitable space if it pressurizes the chimney or vent, unless, of course, a pressure-capable type of chimney is used. If not, then products of combustion will be forced out through the cracks in the chimney. and this can create a potentially hazardous or dangerous condition, of course, due to the presence of carbon monoxide. On the other hand, a mechanical draft system installed at the termination, that can be used on any type of chimney because it maintains a negative pressure or pool in the entire system. Most fireplaces are vented by gravity. However, the fact that we are no longer in the Stone Age is catching up and affecting the way we live today. The first problems we're going to review are chimney related. A chimney may be severely restricted if the inner diameter of the flue is too small. The velocity of the flue gas reaches a point where the flow resistance is so substantial that it exceeds the available draft. This happens when chimney is relined and the chimney reduced, or one-sided fireplace is converted into a see-through fireplace. Perhaps the chimney was improperly designed or undersized to begin with. Maybe the existing chimney is used for a fireplace it was not designed for in the first place. Possible solutions are to redesign and rebuild the chimney to meet the draft requirements, install a heating appliance that does not exceed the capacity of the existing chimney, close off one side of a see-through, or reduce the opening of the fireplace. Or you can install a mechanical venting system. While increasing the flue size increases the capacity of a chimney, it can potentially reduce the available draft. Gases move more slowly in a large flue, and a large flue has more thermal mass and more surface area than a smaller flue. More heat is transferred from the flue gas to the chimney and the chimney walls, which adversely affects the draft. This occurs when a stove or fireplace insert is connected into an existing chimney that previously served a wood-burning fireplace. A wood-burning fireplace is converted into a gas fireplace and the existing chimney is used. This can also occur when a set of gas logs is installed in a wood-burning fireplace. Also, this can occur if the chimney isn't properly designed to begin with. Possible solutions include relining the chimney to reduce the flue opening and match the requirements of the appliance it serves. Another solution is to convert the gas fireplace back to its original wood-burning design. Or, of course, you can install a mechanical venting system. A tall chimney creates more draft than a short chimney. Chimney height and the difference between flue gas and the temperature of the outside are major factors which influence the amount of draft. A rule of thumb for minimum height is a total system height from the bottom of the appliance to the top of the chimney of not less than 15 feet. If the chimney is too short, it could also lead to improper termination. The termination should generally be at least 3 feet above anything within 10 feet of the chimney. Now, this problem can occur when the chimney is on a slanted roof or if the chimney is improperly designed to begin with. Possible solutions include extending the chimney by adding chimney sections or tiles. And if the system meets the recommended minimum height and draft problems are still experienced, you can extend the chimney height, which may or may not have any effect. You can try it with or by temporarily installing a chimney pipe or steel pipe to verify this, to see if it will in fact solve the problem. Or, of course, another possible solution is to install a mechanical venting system. Increasing the height of a chimney increases the draft. Draft increases in proportion with chimney height, but only to a certain point. At some point, additional height gives flue gases more time height. This problem can occur when the chimney is serving a fireplace in a multi-story building, let's say an apartment complex. A large part of the chimney is exposed to the outside. Possible solutions include reducing the height, insulating the chimney, or installing a mechanical draft system. If one or more sides of a chimney are exposed to the outside, the chimney can experience excess cooling, which will reduce the draft. The chilling effect can be so bad that the exhaust gas is not able to create any draft at all, at least not during startup. The best location of a chimney is within the building, so only a very small part of the chimney is exposed to the outside. This problem can occur when the chimney is installed on an outside wall, or the chimney is not insulated, or if the chimney is installed in a location that meets code, but its location is detrimental to proper draft. Possible solutions include relining the chimney and or providing better insulation. Another solution is to install a mechanical venting system. A chimney can be obstructed by debris such as leaves, mortar left over during construction, or an animal or bird building a nest. Creosote buildup could also be blocking the flue or the chimney cap. Blockages might occur in deteriorating chimneys if parts of the interior collapse. This problem can occur when the flue liner is deteriorating, or if bird nests have been built outside of the heating season. Possible solutions to this are to scan the inside of the chimney and search for obstructions and blockages. Repair if deteriorations are found. Remove any animal nests and clean the chimney for creosote or debris. Generally speaking, there should be a 1 to 10 relationship in the cross-sectional area between flue size and fireplace opening. A 24 by 36 fireplace opening equals 864 square inches, so the cross-sectional area of the flue should be at least 86 square inches. This is equivalent to about a 10-inch ID flue. This problem can occur when the fireplace has been redesigned to add more front area. This problem can also occur if the fireplace is not designed properly to begin with. Possible solutions are to reduce the opening by installing a steel shield at the top of the fireplace, like a smoke guard. The height can be determined by using the 1 to 10 rule. For example, the fireplace opening is 40 by 25, or 1,000 square inches. And the flue size is a 10-inch ID, or 86 square inches. You want to reduce the fireplace opening to 860 square inches by blocking off 140 square inches on the top, or across the top. 140 divided by 40 equals 3.5, which should be the height of the shield. Now you can also reduce the opening by rebuilding it. And if the lintel is less than 6 inches, then it should be extended. If the lintel is less than 6 inches below the damper assembly, it should be extended. Or a shield, as described above, should be in place. Another solution is to install a mechanical draft system. The lintel prevents smoke from rolling out by capturing and containing it. It serves the same purpose as the front edge of a kitchen hood. If it is too deep or too small, it may not be able to capture and contain the smoke. Now, this problem can occur when the fireplace is not designed properly to begin with. Possible solutions to this type of draft problem are to increase the height of the lintel. Another solution is to decrease the depth of the lintel, or install a mechanical draft system. Another heating appliance related problem is that the smoke chamber is improperly designed. The smoke chamber guides the smoke towards the chimney flue. If there is no smoke chamber, or if it is too low, the smoke stays in the throat of the firebox and becomes turbulent, after which it will start spilling. The smoke chamber should be centered with the sides angled no less than 45 degrees. It could also be that the inside construction is irregular with protrusions. This can occur, or this type of problem can occur, when the fireplace is not designed properly to begin with. Possible solutions include increasing the height of the smoke chamber, parging the smoke chamber walls, or otherwise smoothing the sides, or install a mechanical draft system. Among critical fireplaces is the see-through fireplace, a fireplace that is open to 2 rooms. These types of fireplaces must capture the air in the same way as an exhaust hood, which requires good draft in order to maintain a high velocity over the fireplace opening. Very often, turbulence can be experienced inside the smoke chamber, and smoke problems can occur. This problem can occur when a fireplace was converted from a one-sided fireplace into a see-through. This can also occur when a smoke chamber is non-existent. This problem can also occur when the opening into the rooms are with a different pressure. So one room, say, has a stairway or vaulted ceilings, and the other one does not. Possible solutions are to close one side of the see-through fireplace, or redesign the smoke chamber to provide a better flow, or redesign or rebuild the chimney to provide the proper draft. And of course, you can install a mechanical draft system to solve the problem. Performance problems can also be experienced if the appliance is in the wrong place. The chimney is put in an impossible situation where it is not given a chance to work. Now, this problem can occur when a fireplace or stove is located in the basement of a building. The chimney makes too many changes of direction or too many elbows to get the flue gases from the appliance to the outside. Possible solutions to this are to redesign the venting system, if possible. You can also remedy it to increase frontal velocity, including the following: increase the chimney height using the same flue area, and extend the last tile 6 inches or more upward. You can decrease the frontal opening by lowering the lintel or raising the hearth. And you can increase the free area through the damper. Ensure that it is fully open and without interference. And last, the ultimate solution is to install a mechanical draft system. A heating appliance needs air for combustion process. If the building is tight and the proper amount of combustion air cannot be supplied, a smoking fireplace or stove may be the result. If opening up a window or door close to the fireplace solved the problem, an outside air supply should be installed. This type of problem can occur when the house is built too tight to begin with, new and better insulated windows have been installed, or the building has been properly insulated. Possible solutions are to install a properly sized outside air intake ducted to the bottom of the fireplace. This must be relatively large and should in most cases exceed a 6-inch ID. Actual size depends on the fireplace opening. It could be powered by a fan or blower, and you want to provide supply air to the room in which the fireplace is located. You can install a mechanical venting system, but make sure that the air can be drawn into the room in which the fireplace is located. and also make sure it does not adversely affect the operation of other heating appliances like the home's furnace. Draft is highly dependent on barometric pressure and temperature. On a hot, humid, and rainy day, there is not much natural draft in a chimney, and the flow may reverse, causing it to produce this odor. This is more of an indoor air quality problem than a draft problem. The chimney may work fine once a fire is built in the heating appliance. Possible solutions are to have the chimney cleaned thoroughly and make sure all creosote has been removed. Another solution is installing a tight chimney cap. Installing a tight-fitting chimney top-mounted damper may also help, or installing tight-fitting set of glass doors. Another solution is to install a mechanical draft system. Stack effect is a symptom primarily experienced in multi-story buildings. The stack effect itself is not a problem. It is a very common phenomenon in high-rise buildings or in multi-story homes, where it is enhanced by the existence of elevators that constantly change the pressure when ascending and descending. Efforts to control the stack effect often lead to a pressurized building. So by solving one problem, another and possibly worse problem could be created. This problem can occur when the fireplace is located in a basement or the bottom of a multi-story building. Possible solutions are to install a mechanical air supply fan to provide air into the building close to where the heating appliance is located. Another solution is to isolate the heating appliance from the negative pressure by building a room to place the appliance and supply combustion air to that room. You can also install a mechanical venting system. Installing a mechanical venting system is often the simplest, most effective, and least expensive solution to the stack effect problem. Other solutions can interfere dramatically with the building operation or lead to dismal energy efficiency. It doesn't take much to affect the draft. A tall tree in the vicinity of a chimney can create turbulence that, at times, may cause spillage in the heating appliance served by the chimney. A problem like this could literally have been growing over the years. It is not uncommon that a fireplace that has been working well for years suddenly experiences draft problems due to trees growing around the building. Now, the possible solutions to that are to raise the chimney, or you could simply cut down the trees. Another solution, of course, is to install a mechanical draft system. Just like a tree, the neighboring building can cause similar problems. It may be a taller building that affects the wind flow patterns or cause flow reversal in chimneys. This problem can be caused by a new building that is being constructed on the neighboring lot. Possible solutions are to raise the chimney or install a mechanical draft fan. A building in a valley can find itself in a low pressure area called an inversion, which can adversely affect the draft. Inversions are common in hilly or mountainous areas. A building surrounded by taller buildings can experience similar problems. Your only solution here is to install a mechanical draft system. And last, we have the wind-induced downdraft problem. Now, this is a common problem and is often only occasional. It may occur only on a windy day when the wind is blowing from a certain direction. Wind-induced draft or downdraft is caused by eddies or flow patterns around the building and the chimney. This problem can occur when the downdraft can be caused by wind loading. This is a scenario where eddies or flow patterns create an unfavorable draft condition. When the wind hits one side of the building, it tends to create pressure changes on the opposite or leeward side. This phenomenon can create pressure changes inside the building, which can adversely affect fireplace operation. This is often experienced at oceanfront or lakefront properties, and ones located in mountainous areas. Possible solutions are to install a chimney cap, extend the chimney beyond the eddy, or install a mechanical draft system. Before we wrap up here, please remember that when sizing up a fan for a project, we suggest you go online to our website, chimneyfans.com, and use our fan selector. Not only can the fan selector program help you determine which size of fan to use, it can also help you select the size of chimney to use, and therefore what damper size you will need as well. Sizing charts are available also in our hearth venting manual. For any unusual or oversized jobs, please contact us for assistance. Also, while you are there on our website, you can register to become an ENERVEX dealer if you have not already done so. Just click under the Where to Buy and enter the information, and it will send an email of your application to us. This will help direct homeowners in your area and their inquiries and business to you. Technical support is also available Monday through Friday, 8:30 a.m. to 5:30 p.m. Eastern Standard Time. So let's review what makes the ENERVEX mechanical venting systems a great solution to your customers' venting problems. You can use a venting or a mechanical draft system so that the customers can keep the look of their current fireplace. Using an eco damper system, or an eco damper, it eliminates the need for glass doors. For gas fireplaces, it is completely automated, and no major reconstruction is necessary. The fan system is low profile, and with use of an eco damper, it conserves the home's energy. And finally, it's guaranteed to work. Chimney size, design, location, and weather variations can have a large impact on a gravity-vented chimney system. Misconceptions and misapplications caused these systems not to function as they are expected to. There are also many misconceptions about mechanical venting. While there are sometimes may be hesitancy to install a mechanically vented fireplace system because of a lack of knowledge or familiarity, mechanical venting is a safe and efficient way to vent a heating appliance. This concludes our presentation. Does anyone have any final questions? We will take them now, and any we cannot get to, we will email you with the response.